sequence in operation of voice network and data network, and we understood that the wastage gets drastically reduced, minimized in data network, and that is the reason future is towards data network. So then we will come back to these things, don't worry, but as of now we will jump into the layering. We started off this. Uh, okay, let us spend a couple of minutes here. As we all know that no hardware can work alone, so the patch cable, you know what patch cable is, the LAN cable which is getting inserted into the LAN port of your desktop or laptop, the wired LAN connectivity. So that patch cable, can it just work like just like that? It cannot actually. It's a piece of hardware. It needs to be governed by a software. Then only the communication happens. So sending data through raw hardware is awkward and inconvenient, doesn't match programming paradigms well. So it would be more like electricity uh, current transmission, if we put it that way. But we have other ways to do it because our job is really, really difficult. We are trying to send a piece of message from my local machine to say a server, so-called server. We will talk about that today if time permits or not, if not in next class. So we are sending data from my machine to California machine, and we are getting a message back within next 5 to 6 seconds. So that's a lot of distance traveled in a very short span of time. So the job is complex. So you need to take help of software along with hardware. Protocol, we just talked about it, it's a set of rules. We will see there are n number of protocols to transmit this single www.google.com request to your so-called Google server. So it's basically syntax and semantics taken together. It comes from the Greek word protocol. And by the way, I have shared this slide set in your this thing in your Telegram channel. You can always have a look at it. You can refer to Kudos Ross book, Top-Down Approach of Internet. Kudos Ross, multiple author. Internet, a top-down approach. Some of the slides are from Kudos Ross book. Some of the slides are from Browsen book, Data Communication and Network. So let us move into this. We started off our discussion in this line last week. So whenever we are traveling via air, this is the process. Purchase the ticket, say we purchase online, then everything is happening online, but the traveling, you cannot travel online actually. So you have to load yourself in an aircraft to go to some other place. So your baggage gets checked in, check-in baggage. Then with the cabin baggage, you go and get your seat, find your seat, get settled there, takes off, routing happens, airplane, the air routing happens. Because of the communication between the pilot in the cockpit and the nearest air traffic controller on the ground. Then it lands in the destination airport. You come out with your cabin baggages. Then you claim your check-in baggages from the conveyor belt. And general psychology is, human psychology is, if there is no problem, we just move out of the airport, take a cab, go to our destination. Or if there is a problem, the handle has come out or there is a screw which has come out from the handle, we will go and shout at the officer at the exit. So that's the feedback part. So this is the whole process. Now, if you try to logically group them, if you have purchased a ticket, then there should be a feedback coming out. Checked in baggage, you must claim that. You have boarded yourself in the aircraft, you must come out. It has taken off, so it must land properly, and obviously routing must happen properly, then only the landing has happened. So every group here, you can understand, those are basically connected, logically connected type of work. They're almost similar type of, in fact, not almost, they're similar type of work. Now, when you distribute this among two different airports, the source and the destination, this is how it will look like. Departing airport, those are the jobs I'm doing. And at the arriving airport, those are the jobs I'm doing. And I understand that they are logically connected layer-wise, the way we have seen it in the previous slide. And intermediate air traffic, it's the routing which is the job done. So basically, I am going from here to Bangalore, and this is the process I have to follow. So if I am going from here to Bangalore via an aircraft, physical aircraft, so if my data is going from here to California, why won't it be in similar lines? I am going from here to Bangalore. This is the process. My data goes from here to California. Why should it be different? The approach should be same, because this process has been made by us human beings, and my data going from here to California, that process has also been developed by us, the human beings. So basically, these two will be almost similar in nature. Easier said than done. So layering, whenever, forget about computer network, is it like, say in our university, there is a hierarchy of officers and faculty members. Is not it so? If instead of a hierarchy, if there was a single person, I was talking about it last week, if you remember, if there is a single person doing all the things, do you think it is possible? Okay, that person may be a superhuman being, so it may be possible. But is it logical? The answer is clear no. The answer is absolutely clear no. There's a call from TCS. I'll just disconnect that. প্রলয় আমি আপনার সাথে একটু পরে কথা বলবো, আমি ক্লাসে আছি, কেমন? Okay, okay. Thank you so much. Thank you. Sorry for the interruption. I had to take the call. It was from TCS. So, yeah. Now, so basically, is one person capable of doing all the jobs? The answer may be yes. That person is a superhuman being. But is it logical to assign all the jobs to one person? The answer is a clear no. So if that is so, then taking the data from here to California and the reply back from California to Kolkata, there are so many jobs to be done. So let us divide logically among few layers. Each layer is responsible for one or more than one type of job. So basically, say faculty member is responsible to prepare you for your career. Now, exam control section is responsible to take care of your results, your degree certificates, etc., etc., right? Placement department, they try to coordinate with corporate to give you opportunities to sit for campus placement. So every department here in any university academic governance system has its own responsibility. Similar thing happens when you are taking data from here to California. So let us introduce our first model, OSI model. It's a 7-layer model. OSI stands for Open System Interconnect. That part is alarming. I just had a look at the total attendees. It's 287, and I know there are few faculty members who are attending this as well. They are in this class. So basically, hardly around 280 students out of 750 plus, they are attending the session. So shows the number of serious students in your batch. Good. So it's a 7-layer model, OSI model. Application, if I go top down, application, presentation, session, transport, network, data link, physical. During our studenthood days, we used to memorize this. Later on, we realized that there is no point in memorizing it. It's very logical in nature. But nevertheless, at the very beginning, we used to memorize it as APS-TNDP. APS-TNDP. So from top to bottom. Now you need to be careful. There are 2 P's there. Application, presentation. So presentations P and P of physical. So don't confuse among themselves if you want to memorize it that way. This is important. Functions of layers in OSI. By the way, we will concentrate more on the next layer, next model, that is internet model or TCP/IP model. So, but still, we must know that what are the specific responsibilities of OSI model. Layer wise. So if you go from the top, application layer is basically responsible to deal with application specific protocols like FTP stands for your file transfer protocol, SMTP stands for simple mail transfer protocol, which actually governs your emailing system. We will discuss in detail in application layer the architecture of emailing system, how it operates. Then comes your presentation layer, which is basically responsible for presenting the data, representation of the data in some common formats. Then session layer is responsible for session management. So when you are logging into a remote computer or when you are logging into your own authenticated account, so how that it happens, how long is that session kept, even if it is kept idle, how long is it going to remain active? Just for an example, these days you can remain logged in Gmail, your Google Mail account, throughout the day without doing anything. It does not log you out. But does that happen that way in case of internet banking? Absolutely not. You remain inactive there for a certain time period. The threshold is breached, crossed. It will log you off on its own. It's not its own. Right. Next is your transport layer. Transport layer is mainly responsible for reliable or unreliable delivery of data. We will talk about it. In fact, as a matter of fact, I will be talking about application layer and transport layer in detail in this course. I'm coming to that next. Let us go to the next model, then we will talk about it. Right. Reliable or unreliable means we will discuss. There are some applications in which you cannot afford to miss even a single bit of data. Say you are reading an email, whatever has been sent to you, I hope you understand that every bit of that information must reach to you without any error. Then only the meaning of the email will be proper. Otherwise, say, hi, how are you? If this line, the O is missing, many of us are enough intelligent to understand HW means how, but that is not proper English, right? The SMS language, the WhatsApp language which you use, that's far different from the original proper English. Anyway, so if the letters are missing midway, that is not a proper email, right? That is not a complete email. So email is just an example where whatever amount of data has been transmitted, every single bit of it must be received by the receiver, that too without any error. That's the requirement of reliable delivery of data. But whereas in case of, all of you have encountered this, in case of a video file, which is actually say lakhs and lakhs of static frames played back so that it looks like it's a video. Out of those lakhs and lakhs of static frames, if one or two frames are missing when it was transmitted from sender to receiver, that will not hamper your viewing experience, right? But has all the data been transmitted? The answer is no. So basically, this is unreliable data delivery without hampering your purpose. Will you be able to understand the video if only one frame is missing? The answer is yes. So it is not hampering your purpose, but was all data delivered? The answer is no. Unreliable data delivery. So transport layer, there are two protocols actually, TCP and UDP. TCP is responsible for reliable data transmission and UDP is responsible for unreliable data transmission. So we will discuss them in detail. Then comes your network layer, your IP address. This term must be known by all of you. So address assignment is the job of network layer. In addition to that, routing. Which route the communication should take so that the data reaches from sender to receiver is basically the job of the network layer. The routing algorithms we will study in network layer. And you will be pleasantly surprised to see that you already know many of those because of your knowledge in mathematics, specifically graph theory. So many of you already know those things. In fact, all of you. Now, data link layer is mainly responsible for formatting of the data in frames and delivery of the frames through network interface, something known as NIC, the network interface card, which is that whenever you are connecting your wired LAN cable, right, your Cat5 or Cat6 cable, and at the front of it there is that RJ45 connector. That RJ45 connector, you are connecting it to a piece of hardware inside your laptop or desktop. Click sound happens, right? So basically you are inserting into the port of the network interface card, which is having an embossed address on it. Every network interface card has a unique ID embossed on it, MAC address, medium access control. We will learn about it, don't worry. So that is the responsibility of the data link layer to transmit those frames. And what does physical layer do? See, all these things we are talking about from top to bottom, these are basically yes, they are happening in reality, but that is within that small box. But this electromagnetic signal has to travel. It has to travel physically from Kolkata to California and back from California to Kolkata. So that traveling and taking it through the nodes midway, we will learn that in today's class itself. We will see that how data travels. So conversion of the bits to electromagnetic signal is the job of the physical layer. And at the receiving end, it's basically the signal to bits conversion that is the responsibility of physical layer, along with the physical communication, taking the data from X to Y, all those multiplexing, frequency division multiplexing, time division multiplexing, wavelength division multiplexing, all those things come under the purview of physical layer. In fact, in your senior batches, there were two separate subjects actually. They used to learn uh, first two layers in 4th sem and other three layers in 6th sem, the way that your senior batches are learning it. But because we are in your batch, because we are putting more stress on the cutting edge technology like AI, machine learning, deep learning, then natural language processing, big data analytics, cloud computing. Since we are putting more stress on these cutting edge technologies, we have clubbed two syllabus, two semester syllabi in one semester, one course, that is computer network. Don't worry, don't get frightened. We will make it very simple for you because this is a very conceptual subject. If you understand it, it's a cakewalk. And if you don't understand it, there is no way you can mug it up and vomit it on the day of exam. That's not how computer network is understood. It's very, very conceptual subject and very easy, believe me. One of the easiest papers you will have in your engineering career, computer network. So let us go to this. Left hand side is basically at the sending end. Right hand side is basically at the receiving computer. And physical network hardware is basically your medium, wired and wireless medium midway between X and Y. This is just an introduction to OSI model I have just put forward in front of you. But we are more interested in this internet protocol stack. Internet protocol stack or internet model, 5-layer model. There is another nomenclature known as TCP, transmission control protocol, TCP slash IP, internet protocol, the IP address. So TCP slash IP model. So internet model, internet protocol stack, TCP IP model, all these three nomenclatures, they mean the same 5-layer model of over. This is basically how the data flow happens over your public network internet. Okay. So it might sound like, or it might look like, okay, it was a 7-layer model and this is a 5-layer model. বাঁচা গেছে দুটো layer কম করতে হবে. I agree to it. দুটো layer কম করতে হবে. But what has been done is there were 3 layers: presentation, session, and application. If you take it top to bottom, application, presentation, session. those three layers responsibilities are given to application layer in this mode. তিনজনের কাজ একজনকে দিয়ে দিয়েছি. So it reduces the number of layers, but the responsibility does not get reduced. ক্লাস নিচ্ছি 11:30 অবধি ক্লাস আছে, তারপর ফোন করছি তোমাকে. আচ্ছা, so sorry for the interruption. Now let us go one by one, and once we move down, you understand that you have already studied that in OSI layer. Application layer, what is it responsible for? For the application specific protocols, FTP, SMTP, HTTP, for the session management, for the presentation of data. We understood this few minutes back. Transport layer, reliable or unreliable data delivery, host to host data transfer, TCP, UDP, these two protocol names we have just uttered few minutes back. Network layer, routing of data, datagrams, okay, just a nomenclature, routing of data from source to destination, as well as addressing, IP, routing protocols, link, data transfer between networking, neighboring networking elements, Ethernet, the cable we were talking of. So you have your wireless interface cards in your devices these days, as well as wired interface cards in your devices these days. And physical is based on the wire or your physical communication. And this one is interesting. This computer is actually the, or your computer maybe, or maybe my computer. And somewhere in the next slide, it will be much easier understood. This is your so-called Google server. Why am I saying so-called Google server? I'll answer that in application layer. So this is your so-called Google server. Now, if you look into it, this machine, your computer, there are 5 layers embedded into it for network communication happening, application transport, network, data link, physical. This guy, your so-called Google server, is also having 5 layers. It's just a computer, right? So there must be 5 layers implemented. By the way, there was this small 3D model has been shown here, this guy, where only 3 layers are shown: network, data link, and physical. That particular entity is known as a router. Okay. Go back to your digital electronics knowledge. What does an adder do? It adds, right? What does a subtractor do? It subtracts. So what does a router do? It routes. It does the job of a postman. So there are only 3 layers shown. Why 3 layers? The computers were being shown 5 layers, but for the router, why only 3 layers? Now, let me ask you, the postman, I don't know how many of you have seen postman. All those days are gone, right? So the postman, when he or she brings a letter to your home, does he or she need to know the content of the letter inside the envelope? The answer is no. He or she only has to look at the address written on top of the envelope, and that is delivered to that address, right? Similarly, the router is responsible to take the incoming data, analyze it, analyze what part of that data? Only the address part. That to which address interface I am going to forward this data to. That is the responsibility of the router. The traffic police. Traffic police sees incoming traffic from east side. According to the signal, at some point in time, it will go to, say, the southern side. Sometimes it will go to the northern side, so on and so on. Similarly, the router only needs to know the address to which it has to forward. That is the reason the 2 upper layers, transport and application, which deal with the actual message that is not required of the router. Router is only responsible, only it wants to know the address to which it has to be forward. Addressing is part of network layer job. So only the three lower layers are being shown, and logical communication, this is it. Data is getting transmitted. This is your machine. You opened up your browser. You typed www.google.com. Through transport layer, logically, it got connected to the application layer of so-called Google server through transport layer of that particular machine, and the response comes back. This is your logical communication of data. Underlying layers key হচ্ছে as end user এতদিন আমরা did we bother? We did not. We opened up Chrome, we typed something, and we were expecting the Google search result to come back to us within few seconds. না হলেই we would abuse the internet service provider. কত ছাড়াগুলো পয়সা নেয় সার্ভিস দেয়, right? But we will start understanding and appreciating that what happens in the background, that why it is taking some extra amount of time in some of the cases. So that is how the logical communication is looking like, that from my machine to Google server machine, there is a request going and a response coming, the home page being displayed on my browser. But that is not the end of the story. This is how physically data travels. My computer, this is so-called Google server, and we have shown one router here, midway. Believe me, this one is actually N router. It can be N, more than one. Now, closely, the data traveling is the physical communication. This is how data travels. Let me repeat this. This is how data travels. Let me repeat it again. Right. Now, let me explain. This is my machine. I typed www.google.com in the address bar of my browser. The application message got created. What was the message? That ইন্দ্রনীল আমি ক্লাসে আছি, 11:30 অবধি ক্লাস আছে, 11:30 অবধি ক্লাস চলছে আমার, অ্যালেক্সাকে বলো। হ্যাঁ, আচ্ছা। So the data at my machine, I type down www.google.com in the address bar of my browser. The data is, the message is being created, and it drills down through from application to transport network data link physical interface. It drills down through all the layers. From my machine's physical layer, it gets connected to the nearest router's physical layer. Then it goes up layer wise. Physical to data link to network in the router. The address resolution happens. It again comes down from network data link to physical. Say there is another router. Let us explain. Router number 2. What happens then? Physical layer of router 1 is physically connected to physical layer of router 2. From there, it goes up data link network. Address resolution happens, comes down network data link physical. Right? If you have understood it for 2 routers, I hope you understand that this is happening for n number of routers. N can be anything. From the last router's physical layer, the physical layer of so-called Google server is connected. They are physically connected. The electromagnetic signal is traveling. This red line is basically your data. Please understand, you cannot take the W and throw it to the other end. It has to get transmitted as a signal. So that signal transmission happens only through physical medium via the physical connectivity between physical layers. be it wireless, be it wired. In all the cases, it is a mix of wired and wireless communication. Next, physical layer of last router is connected to physical layer of my Google server. The data drills up, data link, network, transport, application. Google server understands the message that there is a request coming from a machine from Asia, India, West Bengal, Kolkata, Newtown area. He understands the request, frames the response, sends back the response to my machine. The route by which I came from my home to university is not necessarily the same route by which I am going to go back. I may have come from airport number 1 gate. I may go back from Chinar Park to Damnam Park to my Damnam, my place of stay. Similarly, the data, the path taken by the data from my machine to California machine need not necessarily be the same path taken by the data from California machine to my machine. It can be different path altogether. Who decides that path? The network routing algorithms. The routing algorithms of network layer in different nodes, right? This is how physically data travels. There is a query asked by Shovik Panda, sir, is the IP address changed during the traveling? By the time, Shovik, you have sent a letter to your special friend, there was an address assigned to that house of your special friend. Now you have sent a letter. By the time the letter is reaching his or her house, that special friend changes the address of his or her house. Will the letter ever get delivered? The letter will get delivered. The postman, through different post offices, it will bring it back to you. Best part about computer technology is the data which we are sending, we basically we are keeping a copy of it. But for the letter, generally we send the singular copy. So that copy will come back to you if your receiver changes the address midway, right? But obviously there will be so many IP addresses of so many routers. We will explain those things later on, don't worry. So you have to have your receiver's address need to be unique, otherwise it won't get delivered. Next query is not actually understood. Why two parts, the same layers of router is divided? I did not understand that. Okay, you are basically asking in the picture why there is this cross type of thing written. Maybe that is what you are asking. We will learn that router, it is having multiple interfaces. So it's like a signaling system in a say 4-cross road. So basically the data which is coming from one interface, we have common sense says that it will not be forwarded to the same interface, right? Otherwise the data would not have come. গাড়িটা যেই রাস্তা দিয়ে আসছে সেই রাস্তাতে আবার ফেরত চলে গেলে তাহলে আসছিল কেন? ঠিক? Similarly, data is coming from one interface of the router. So basically it won't get forwarded to that same interface, it will get forwarded to some other interface. So those two crosses, they are basically showing the multiple interfaces of the router. That is the meaning of that picture, don't worry. Yeah. So there is a query like, sir, is it actually the undersea cables? Undersea cables, is it true that internet connectivity, those are the basic backbones? The answer is yes. In fact, I don't know how many of you remember that. It is sometime in 2009, May, there was this cyclone happening. What was that name? Ayla, right. Ayla was devastating. In fact, because of Ayla, there were these cables, undersea cables, internet connectivity cables torn because of Andaman Nicobar region. and the internet went down for a sizable amount of time in a big region of India. So yes, eventually you have to see the physical infrastructure must be there to take your data from X to Y. If that physical infrastructure gets destroyed or not completely destroyed but partially damaged, obviously the communication will get hampered. This laptop is also a part of that whole network process. From here, the data, the message is getting generated, the reply is coming back. Now, if this laptop goes down, obviously our communication will get hampered, is not it? OSI is the model name and ISO is the organization. Okay. So it's like Microsoft and Windows. We keep on saying, but we keep on forgetting that Windows is the product and Microsoft is the company. I mean, that is the thing of branding. Dettol. Dettol has become such a brand. Very few people know that which company produces Dettol. They don't bother to know. Same applies with Savlon. Oh, okay. One student is asking what is the difference between router and Bluetooth. Bluetooth is a communication technology and router is basically a device. We will learn about different types of communication technologies. In fact, one of our professors will be taking one session on that as well. Okay. So that answers few of the queries. Again, let me go back to the slides. Yeah, so we discussed it. Now let us come to this. Encapsulation of the data, this is basically at the sending end, the sending machine. Those three upper layers constituting your application layer, say we are considering a reliable data transmission requirement, say email. So upper layer data is generated from your application layer. Then it drills down, see the arrowheads. Now that gets appended with TCP header. TCP is the protocol. What does it do? We will learn. But basically, transport layer adds its own identifier. Put it that way, right? For the time being, let us understand it that way. The transport layer puts its own header, its own identifier. With the message, adds its own identification header. Then it drills down to network layer. Please see this yellow mark. Now, your whole thing, the message and the TCP header has now become your data in the network layer. That is the data in your network layer with which the IP header is added from the network layer. The network layer protocol is Internet Protocol or IP. That whole thing now becomes data in the data link layer. There you add couple of headers, logical link control, medium access control. We will talk about them in detail in this thing, data link layer. FCA stands for frame check sequence. Don't worry, you'll learn those. There are nomenclatures given at the right hand side. At the transport layer, we are calling it segment. At the network layer, we are calling it as packet. At the data link layer, we are calling it as frame. And please understand, the previous layer header added becomes the data of the next layer. The picture is self-explanatory. At the top of the physical layer, that is at the end of data link layer, you have the bit stream. What is that bit stream consisting? The original message appended with TCP header, if it is TCP used. If it is UDP used, it is UDP header. So original message appended with TCP header, IP header, LLC header, MAC header. The whole thing now has become your bit stream. What is the job of the physical layer? Converting this bit stream into signal, electromagnetic signal. Once that happens, that signal travels from physical layer to physical layer as per this slide. We have explained it in detail. This is at the sending computer, sending end. This is at the receiving end. This is what happens. The signal comes to the physical layer. Physical layer converts it to bit stream. Okay. Now you can see the data is drilling up, going up. In the previous case, the data was coming down. Now at the receiving end, data is going up. From physical layer, it goes to data link layer. And in the process, the MAC header and the LLC headers, those are chopped off. Those are discarded, chopped off. From data link to network layer, network to transport layer, in the process, the IP header, the TCP header, all those are getting chopped off. Fine. Eventually, it reaches the application layer of your so-called Google server. So-called Google server. It reaches the destination. The destination machine understands there is a request for the copy of my home page. If you have requested for www.google.com, it understands there is a request for the copy of my home page coming from such and such machine somewhere at the other part of the world. How did it understand? Because of these headers. IP header, TCP header, everything has its own job, which we will learn in due course of time in this particular subject, right? So now the application layer of the destination understands the request. It frames the response. Once it frames the response to be sent across, I hope you understand this is the sending end picture. Now the data will be sent by that so-called Google server in this manner. It will come to your machine. Your machine will understand and display it on your browser in this manner, because now your machine is the receiver. Google server has become the sender for the response message. So this is at the sending end. This is at the receiving end. As simple as that. There are a couple of queries, I think. Gaurav is asking, sir, is it like every time it has to pass through more than one router? The answer is no. There are cases of communication where one router is sufficient to take the data from source to destination. Yeah, someone is saying if IP is removed, then how will the data get delivered to destination? That's what we discussed. You do away with the receiver's address, how will the postman will be able to deliver the letter to the proper address? ওই বাড়ির অ্যাড্রেসটা যদি মুছে দিই তাহলে বুঝবে কি করে postman? The postman won't understand the address of that house, right? So you cannot do away with the IP address of the destination. It has to be there. Otherwise, the data does not get delivered. I tell you, just come to my house. You will say, sir, what is the address of your house? I will say, bolbo na. I won't tell you. You come to my house. Is that possible? Right? So, you answered yourself. Great. Yeah, there is a query that how does the speed of internet varies in different types of connection? We'll discuss. Don't worry. We'll get to understand that all the multiplexing, you will realize. You answer it yourself. When you are traveling via Red Road on Monday morning 11 o'clock, the time taken from the starting of that road and ending of that road, will it be same on a Saturday night at 2 a.m. or Monday early morning 2 a.m. same distance? Will your car take same time? The answer is no, right? Because on Monday morning 11 o'clock, the congestion in that road is tremendous. Whereas Sunday 2 a.m., there is no congestion. So we will discuss in detail in transport layer, network layer, all those mechanisms, flow control, congestion control. We will learn those, everything. Don't worry. Okay then, it's 11:19 now. I will close the session here. Thank you for your patient hearing. And we will continue from this portion in our next class. We will start off with application layer, right? Thank you. Thank you so much. Attend the next session, attend the next class of faculty member. Thank you. Bye-bye. Have a nice day. Bye.